Now that we have seen what variables are and how they can be used in order to use names to refer to memory locations or values rather than to directly remember their memory locations or addresses and so on, right. What can we do with those variables? How do we combine them together in different ways? And that is where the concept of operators comes in. So, at a high level, what is an operator? An operator is essentially some way of performing a computation, right. So, the kind of things that you actually want a computer to do, the computations, are usually expressed in terms of operators, right. They can also be used in order to update the values of variables, right. As we will see, the equality, the assignment symbol in C is actually an operator, right. Now, it is a little difficult to exactly give a hard and fast distinction between what is an operator and what is a function, right, because you might find in multiple places that things that you might otherwise think of as functions are suddenly called operators, right, and there may be contexts in which something that you think should be an operator could actually be implemented in terms of a function, right. They are very closely related. In general, operators are at the mathematical level, they are supposed to be working at a slightly higher level than what a function is doing, right. But as a programming language, at least what we are talking about over here is that they are, and we are more interested in a much more simple and elementary way of understanding what these constructs are, right. Typically, in a programming language like C, we use certain keywords or certain symbols, right. The majority of operators in C actually correspond to certain symbols which are non-alphabetic, right, and which perform certain specific kinds of computations, right. But not all operators need to be symbols. There are certain keywords that also define that are used as operators, right. One of the things to generally keep in mind is, in most cases, the operators are something whose the definition is sort of decided at the compilation time itself, right. So, it is not something that can be dynamically determined at runtime in general, okay. For the most part, you do not need to once again be too rigidly bound by the distinction between an operator and a function. What is important is knowing what are the available operators that are there in the language and how those operators can be used in order to construct expressions, because after all, expressions are the result of any computation, right. Anything that gets computed is an expression. The result of that is then going to be used somewhere else. Now, the most obvious kind of operators that we can think of would be what we call the arithmetic operators, right. And when I say something like I is equal to I plus 3, you would naturally say that yes, the plus looks like an operator, right. Essentially, that is kind of what you would intuitively assume is an operator, right. It basically takes the value I, it takes the value 3, it adds them together. Like I said, this sort of looks like a function which takes two inputs and gives an output, right, but this is explicitly operating on these two values. It has a certain order in which those particular computations are performed. The semicolon at the end, by the way, is just a separator between statements. It is not really required as part of this expression that we have here, right. So, the addition operator is probably a no contest, right. Everybody sort of intuitively understands that this is an operator, it operates on two inputs and gives a value. What is not so obvious on the other hand is the fact that the equal sign is also an operator, right. What it does is it takes everything that is on the right hand side and assigns it, updates the value which is there on the left, right. And in the context of C, once again this is considered as an operator. It causes an update of a value that is present in the memory, right. In general, the behavior of operators in C is fixed. Those of you who are familiar with other languages, in particular C++ or Java, would have heard of this concept of operator overloading. It is something that is used a lot in other kinds of languages in order to sort of provide new meaning to certain kinds of symbols, right. So, a plus can be defined such that it can basically take two strings and add them together. You could even in principle define a plus operator that takes an integer and a floating point value and actually does something else with them completely, which does not even look like addition, right. Now as you can imagine, that is a recipe for disaster, right. People expect to see certain kinds of behavior when they see certain symbols. If you redefine it to something else, it is only going to cause confusion in how people understand your code, right. C does not in general allow operator overloading, right. So it is pretty much fixed behavior that you have over there, you cannot redefine it. And there are of course specific syntax rules that are there in terms of how you use these operators, right. So for example, one of the things that we can do is this I is equal to I plus 3 could also be written in a slightly shorter form as I plus is equal to 3, right. And I plus is equal to 3 would essentially say that it would take the value 3, it would add it to I and it would give you an updated value. Now on the other hand, I is equal to plus 3, although I have marked it wrong over here, it is not syntactically wrong. Syntactically this is okay, right. What it would do is it would take the value plus 3 and assign it into I, right. The point is that the order of the operators matters, and by changing it around over here you get a completely different meaning, right. So this would basically assign plus 3 to I, whereas this would add 3 to I, right, and you get completely different results. So that is something that you need to keep in mind. Of course, this was a particularly simple case where it turns out that both of these orders actually do have syntactically correct meanings. In general, if you were to change these things around, it can also result in something which is completely syntactically incorrect, okay. But that is just pretty much part of the programming language, right. I mean, it's sort of like saying that that's essentially what syntax is about. What it says is, if you make something grammatically incorrect in any language, then it cannot really be understood. But it is also possible to have grammatically correct sentences that with the same set of words that have very different meanings. That is what you need to watch out for when you write code. Now there are a whole bunch of other arithmetic operators. The plus is for addition, minus for subtraction, star is for multiplication. Slash is used for division. This, like I said, is usually called the forward slash operator, or just slash is used for division. This is usually the remainder operator, right, the modulo operator. But some of these operations can also be type dependent. What I mean by that is, if I use 5/2, in this case both 5 and 2 are automatically interpreted by the compiler as integers, which means that it actually invokes the division algorithm for integers and comes up with the result 2, which is also an integer. On the other hand, if I do 5 divided by 2.0, right, this 2.0 is treated as either a float or a double precision number depending on how the compiler is set up, right, and it will then automatically typecast, right. It's effectively what's called a type promotion. It takes the integer and converts it into the same type as what this 2.0 is. So assuming that they have both got converted into floats, it does 5.0 divided by 2.0 and comes up with the answer 2.5, which is once again of the same type float. So certain kinds of type promotions and so on are done automatically by the compiler, but you need to be careful, because where you need to really watch out is when you write 5 by 2 and then finally realize later that that's not 2.5. Okay. Now the interesting thing is the C programming language, the specification assumes that multiplication, division and so on are present. Okay. But it's quite possible that you are trying to write a C compiler for a machine or a CPU which does not have hardware multiplication or division, right. That's entirely possible and it's entirely within what is permitted as per scope. What is supposed to happen then is that your compiler, the runtime provided by the compiler, should automatically provide an implementation of star and slash, or it might choose to actually give an error and say that this is not supported by the compiler for this particular architecture. But in general, what is usually done is that the C libraries will take care of implementing the right kind of functionality. Right? One other thing to keep in mind over here is there are certain functions like, for example, square root and sine, cosine and so on, which are available as part of the C libraries, not the standard library or the most basic core library, but something called the maths library, which is very commonly used in C. These are not keyword operators, they are actually implemented as functions, right. So once again, all that it's doing is it's sort of telling you that yes, just like you could have had multiplication as an operator, you could potentially think of doing square root or sine as also, you could think of it as an operator, but in this case it's implemented as functions instead. Okay. Now another operator which can be a little confusing if you are not familiar with it is what's called the ternary operator. Right, and what the ternary operator does is it basically takes three components, right. It has these three elements here, this is element 1, this is element 2 and this is element 3, right. And what it does with these three is you have the question mark, and what it does is it basically says, okay, I will check the sort of logical value corresponding to this, is this true or is it false. If it is true, it will take the first value after the question mark. If it is false, it will take the value after this colon symbol, right. So this entire sort of structure, this question mark and colon combined together are called the ternary operator, right. So you can see that it's actually two symbols that go together, right, but can be separated by spaces and other things in between them, but only when combined together they become the ternary operator. Now obviously, as we will see later when we get to flow control, you could also have done this as if x greater than 10 minus 3 else plus 5. Okay. This particular notation just turns out to be more compact and in a lot of cases can actually allow you to express things neatly and quite in a very condensed manner, right. The problem is it can also result in what is called obfuscated code, and this is one of the classic problems with C, right. C is a language that's very good for writing what's called obfuscated code. Obfuscated basically means hidden, right, or rather where the meaning is hidden so deep that it's essentially impossible to understand it, right. To the extent where there is actually a programming contest called IOCCC, the International Obfuscated C Code Contest, right, and it's just about how confusing you can make your code or how difficult to understand, while at the same time producing some interesting looking results out of it. Okay. So in general, the only advice over here, just like with many other sort of potentially useful yet potentially problematic parts of C, is use it with care, right. Do not just sort of say, oh, it will never be used, because there are places where it makes the code easy to understand, but at the same time avoid using sort of nested ternary operators, which can be done, and also try and use it only where the if else is very obvious and easy to understand. There are other operators in C which are called the pre-increment and post-increment, or the pre-decrement and post-decrement operators, right. Increment essentially takes a particular value and increases it by 1. Decrement takes a value and decreases it by 1. Okay, so it's always by 1, it's either plus 1 or minus 1, right. So increment and decrement turn out to be very common kind of scenarios that we encounter, primarily because of the concept of a loop, right, where we want to repeat a given set of instructions many times. And for whatever reason, the creators of C decided that having a shortcut or a shorthand for that would be useful. This particular notation I++ is one of the things which is used in order to do increment. Okay. And what it says is, let's assume that I is equal to 3 to start with, right. Somehow I has been declared as an integer and I set I is equal to 3, right. If I then issue the command I++, right, it will cause I to get incremented, right. Plus I also increments it. So now since I has got incremented and has become 4, plus I will now make it 5. Okay. So far so good, so then why two different notations, right? And this is where the concept of pre and post comes into the picture. The post increment basically says that I will first, if I was using this as part of an assignment, right, or if I am using that value I somewhere, I will first use the value of I, and after I am done with whatever I wanted with it, I will increment the value of I. Whereas plus plus I says I will first increment the value of I and then use it wherever it is supposed to be used. Okay. So what does this mean? How exactly do we go about using this, right? This is where things start getting confusing. What happens if you give a statement like this, j is equal to plus plus I, right? Let's interpret it, start looking at the right hand side first. What it says is I want to pre-increment I, right? So before I assign it to j, I want to increment it. That sounds reasonable. So I will increment I, it becomes 6, then I will assign it and j will become also 6. What if I do a post increment on the other hand? Then what it says is, assign the value of I to j first. So j gets the value 6, which is the current value of I, and then increment the value of I. So I now becomes 7, right? You can sort of imagine where this is going, right? Things can start getting really confusing with this. So to look at it, I've also just got a small replet that takes you through some of these potentially confusing things. So let's take a quick look at that. So this is a REPL that just contains many different variants on the pre and post increment and decrement operators. So I've commented out most of them. I'm just going to show you what we start with, right? I assign a value to I then print out these values, then I start with j is equal to I plus plus, j is equal to plus plus I, and let's see what happens when we run these, right? It's basically going to print out the values of I and j in each of those cases. So if I run this, what I find is, of course, the very first time I is equal to 3 gets printed, which is what I expect. Then the next time around what we see is that j is equal to I plus plus, it's a post increment. First take the value 3, put it into j, and then take the value of I and increment it. When I print out the values out here, what I find is j has the value 3 and I has the value 4 because it got incremented after the assignment. But what about j is equal to plus plus I? This does things slightly differently. It first increments I so that both j and I end up getting the same value 5, which is 1 plus whatever was the value that I had earlier. What happens if I go a bit further though, right, and look at something like this? You will notice that when I do something like I is equal to plus plus I, Replit is already complaining a little bit. This is only a complaint. It's only a warning, not an error, right? You will notice that it's somewhat yellow orangish in color, the sort of pop-up that came over there, right? And it basically says multiple unsequenced modifications to I. And the reason it says unsequenced modifications is because both the plus plus and the equals are trying to modify I, and the order in which that happens is not entirely clear from the way that it's written, right? Sounds a bit complicated. And it turns out that, well, what would we expect this to do? We would expect it to increment I and then take that value and assign it to I, right? So let's see, we have got up to 5 so far. I should hopefully see it going further beyond that. And indeed when I run it, what I find is that it keeps going, right? 6, 7, 8 and so on, right? So far so good. Now what about these statements on the other hand, right, which are also doing something fairly similar, right? Instead of the plus plus I have written I plus plus, okay. But when I run that, what I find is that in this particular case, now when I run it with the I plus plus, I is equal to I plus plus, now things look a little different, right? The I value is not changing. Effectively what it's saying, in other words, is it takes the last value of I that it had, performs the assignment, and then increments something, but that increment is effectively getting discarded, right? So what is happening over here is that the increment part over here is effectively not happening at all. It is getting discarded. Now as you can imagine, this is essentially something which is not supposed to be done, right. So rather than sort of trying to dig deep and say, okay, why exactly is this happening, the only real suggestion to be given over here is don't write code like this, okay. You can do the same thing with minus minus, of course, right, and we can take a look at all of that. With minus minus the same thing happens. If you do a pre-decrement, then it keeps decrementing the value, but the post-decrement effectively gets ignored, right. And then you can go even further and remember that because I is equal to I minus minus is itself an expression, the value of that can in turn be assigned to I. What's likely to happen? The only way to figure this out is to run it, right. You can't really interpret this beyond a point. All that it says is pretty much is not going to work the way that you have. You can also try doing things like pre-decrement, post-decrement and see whether the values differ. Bottom line is, apart from just trying this out for fun, please don't have code like this in any of your programs, right. The fact that this is allowed by the language does not in any sense make it a good idea. Okay, yet another operator that is available in C is what's called the comma operator, right. And one way of explaining it is to say that supposing I have values such as x is equal to 10 and y is equal to 20, I can effectively just have them as two separate statements, right. I can assign x equal to 10 as one statement, y equal to 20 as yet another statement, and it does what you expect, right. X gets the value 10, y gets the value 20. Now what if I do something like a equals x equals 10, now x equals 10 returns the value 10, so a should also get the value 10, right. The comma operator basically says that rather than having a semicolon and making them two separate statements, I could actually use a comma over here and make it one statement, right. And x equal to 10 comma y equal to 20 would also do the same thing, right. But this is where things start getting a little tricky, because if I now use the statement a equals x equals 10 comma y equals 20, right, it actually ends up taking the rightmost value that was assigned within the comma statement and returning that as the value of the overall statement, right. We can check this out also by going over to Replit. Now what the comma operator has done over here is, I first started out with x equals 10, y equals 10, and of course it got the values, or rather y equals 20, and it got the values 10 and 20 for both of those. Now I declare another integer a and say a equals x equals 10, and sure enough a gets the value 10, same as what x got. Y of course got 20, right, which is a separate statement. But now what happens when I give a equals x equals 10 comma y equals 20? Now what happens is, it takes x equals 10, performs the assignment, takes the same value, puts it into a, and then treats this comma as sort of a continuation of that same statement and assigns the value 20 to y. So now once again a is 10, x is 10, y is 20. But the moment I put parenthesis and take that x equals 10 and y equals 20 and put it within brackets like this, it changes, because now what happens is x equals 10 comma y equals 20 when treated as an expression returns the value 20. So a gets the value 20 as we see over here, which is why in this case what you see is that having the parenthesis and not having the parenthesis can make a big difference to the actual value that you get. Now the first question to be asked of course is, what is the use of the comma operator? In most cases just have them as separate statements. When you want to assign values to variables, just use separate statements. There are very few cases where you need to use the comma operator in order to assign values. One of them actually turns out to be useful, which is that there are certain scenarios where you want to initialize multiple variables inside a for loop declaration, right. We will get to that later. For the time being, just put it aside. The general rule of thumb is, because of this kind of confusion, once again this is one of those operators that is preferably avoided, right, unless you have a very good reason for needing to use it. Apart from all of those operators, there are the sort of logical comparisons, right, which are much easier to understand. The only thing, the major point over here is that if I want to compare two values, I need to use a double equals sign, equals equals, right. Remember that a single equals sign is an assignment operator. A double equals is also an operator, but it's a comparison operator. It checks whether two values are equal, right. It's very easy to get the two confused, so please exercise caution when writing code. It's a common source of bugs, right. You can also combine different logical operators together. For example, I can have a statement like x greater than 10 and, or rather an expression like x greater than 10 and y less than 30, right. And in this case, it's kind of interesting that you need to also think about something called precedence, right, which is once again something that we will look at later with examples rather than trying to explain it too much here. All that you need to know is potentially, because after all there is no Boolean operator in C, right. So I could also have a thought of performing an operation like 10 and y, right. The and over here, this double ampersand symbol is essentially the and operator. The double vertical bar or pipe symbol is the or operator. The exclamation mark is the not operator, right. For those of you who have not done digital systems or Boolean algebra, you don't need to worry too much about it. This is essentially just basic logic, the way that we would talk about in the English language, right. If A and B just means that both the conditions are satisfied. A or B means any one of the conditions is satisfied. Not A means that A is not true. That's all, right. What this statement or expression in other words means is I first check whether x is greater than 10, it's either true or false. Is y less than 30, that's either true or false. Then I combine the two. If both the statements were true, then this overall statement, or if both the expressions were true, then the overall expression becomes true. If any one of them was false, the overall expression becomes false, right. Now, given the fact that 10 itself is true and y itself is a number which might evaluate to either true or false, we could potentially have thought of this statement as, or this expression as being 10 and y and give it a Boolean value for that. It turns out that there is something called precedence of operators, in which order should I evaluate them, which says that I should first do things like these comparisons, right, and the and operation should be performed later after I have performed all the other logical operations, right. Once again, this is a convention, part of the language. In most cases, it is intuitively obvious what you need to do, so go with that. Finally, there is also something called the Sizeof operator, right, which we will actually see a lot more of later, right. And the main reason why Sizeof is useful is because it is actually it allows us to understand a little bit more about how much memory a particular variable or a particular data type or even a data structure occupies, right. And the reason why that becomes important is because, as we will see later, there are places where you need to manage the memory used by a program more carefully, right. In that context, knowing exactly how big your different data types and variables are can make a big difference to how you plan and what you place in different parts of the memory that's available to your system, right. Now, one of the sort of more confusing questions over here is, why is Sizeof an operator and not a function, right. Once again, like I said, they are closely enough, operators and functions are closely enough related, close enough conceptually, that you don't need to worry about the difference in most cases. The main thing that you need to keep in mind as far as Sizeof is concerned is, it's evaluated, or rather whatever it is going to make use of is evaluated at compile time, while the program is being compiled, not when it's being run. So when I say Sizeof int, for example, the compiler itself is able to replace that with the number 4 effectively, right, which says an int is 4 bytes long. And one other interesting fact about the Sizeof operator is that it has to return data of a certain type. Obviously, the Sizeof is a number of bytes, so it should be a number. That number could have been an int, an integer, but I also know that a size cannot be negative, so maybe I could be an unsigned integer, right. But what happens in practice is that there is explicitly a separate type that is defined in C called size t, right. This is usually pronounced as size t, right. So, it is basically the size underscore type, size t, which is used just in order to indicate the size or the return value that is given by the Sizeof function, right. Why is this so important and relevant? Part of the reason why you need to be aware of this is because C is a language that goes close to the heart of a computer, right. It actually needs to know things like how big the registers in a computer are, or it is used in contexts where you need to be aware of such information. What that means in turn is that very often you might actually need to know what the size of a particular data type or a variable is going to be, how much space it is going to occupy, and so on, right. And in that context, the Sizeof function is very useful and can allow you to write programs in such a way that it is independent of the kind of features that are actually provided by the computer. So, this was sort of an overview of the main operators that are present in C, right. As you can imagine, they all perform certain kinds of basic functionality. How do you put these together in order to create slightly more complicated programs? We have already seen some examples. There were many operators that were used in the simple program to just add numbers together. Most of what you will be doing in programs will be an appropriate use of operators combined with the different data types and variables that you have in order to perform whatever computation you are interested in.